Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Riza Hadi Saputra from sttmigasbalikpapan. My field of research is applied physics with digital analysis of voltage and electric current in solar power plants based on dual data acquisition using Robotdyn. Okay, for now we go to the introduction. Fossil energy is getting down day by day. This is stated in the data from the Ministry of Energy and Mineral Resources of the Republic of Indonesia that coal, oil, and gas will be exhausted in 2028. Therefore, we need renewable energy to deal with this. One of the best and most widely used in everywhere is solar power plants. Solar power plants use solar cells to capture sunlight, convert into photons, which will then be processed into electrical. The electrical is transmitted through cables for solar cells to battery or loads. The cables is connected to solar charge controller or SCC. There are three inputs in SCC, which is from the solar cell, battery, and load. Therefore, these inputs can be seen only in the field or in the control room. This is the problem. However, the system has a weakness. This has made some researchers take alert at the power plant so that the power plant can normally run. The solutions for this weakness is using cloud system. For the example, the cloud system is a digital storage system where the data obtained will immediately be sent to the database. The data sent is assisted with Robotdyn, one of the microcontrollers who can collect the data. The data from Robotdyn are voltage and electric current. The input voltage is the voltage that comes from the solar cell, while the output voltage comes from the battery to the load, and so does for electric current. The next problem is that the input and output voltage sensor cannot be installed in one Robotdyn, where the maximum limit is only one sensor for each Robotdyn for each type. So in this study, using two Robotdyn for the same time, the discussion for this research is more on analyze the voltage and current in solar power plant. The comparison of the input and output voltage with the measured data will be compared with the data captured in the cloud system. So next we go to the methodology from this research. Look at the diagram block at the side. Okay. The solar power plant is built from 6 solar cells, where each solar cell has a maximum power of 100 VP. Furthermore, the solar cell's output is forwarded to the battery via the SCC, where the installed battery is 24 volt DC with 100 ampere hour capacity. The input sensor is installed before SCC from solar panels for voltage and electric current, and the output sensor is installed before batteries from SCC for voltage and electric current. The data acquisition takes with different Robotdyn. There are two Robotdyn in this study. After that, the data sent to the cloud system and displayed in website. For the real system, my friend will be reported from the laboratory. Hello, my friend.
Hello, my friends. I am in instrumentation laboratory at sttmigasbalikpapan. So behind me there are some diagram blocks from the before explanation. Let's check it out. So this is the diagram block, Robotdyn and the other sensor. This is inverter, SCC, alright. And this is the modem from communication data, and this is the battery. This is the solar cell from the outside of building. Okay. Thank you for attention.
Okay, thank you, my friend. So we go to the result and discussion. This is a figure about realization solar power plants. This is, yes. The solar cell installation is on the roof of the instrumentation laboratory in sttmigasbalikpapan. Voltage and electric current data were taken for 1 week, from 14 August 2020 to 20 August 2020, for a full 24 hours. The data is taken from the cloud system every 5 minutes. So this is the figure of the comparison of input and voltage. It can be seen that the input voltage appear on average for 7 days from 6 a.m. to 6 p.m. from the first day to the 7th day. The voltage that appears range from 25 to 40 volt DC, where the highest peak of the input voltage is at 10:30 a.m. to 3 p.m. The figure also shows the output voltage, which is always stable at 22.7 to 28.8 volt DC. When at 6:30 p.m. to 6 a.m., the output voltage is at stable at 22 to 23 volt DC, which can turn on the load. Next figure is of comparison of input and output current. The peak of the highest current, 11.9 ampere, occurred on Wednesday, 19 August 2020. However, it can be noted that every day there is also an electric current at 6 a.m. to 6:30 p.m. with the peak current at 10:30 a.m. to 3 p.m. and when at 6:30 p.m. to 6 a.m. the incoming current is 0 ampere because no sunlight. But the current output is stable at around 1.5 to 1.8 ampere. You can see the mountain of graph, which the orange, the output, it's still covered with the blue, the input. Yeah. So this also applies to voltage. With the voltage and current analysis that has been carried out and refers to the figures, yes, the input voltage does not take more than 1 day to make it full 100 ampere hour capacity, and for the input current are still massive than the outflow or load current. Environmental effects such as cloudy, rainy, or sunny occur during data collection. On 15 August 2020 and 18 August 2020 is occur heavy rain with cloudy. It can be seen that on day, the voltage decreased slightly, with the maximum average input voltage was 30.5 volt DC and with a maximum current of 7.6 ampere. Even so, the battery was still full every day on a cloudy day with rain where sunlight is not shining on the solar cell. Okay, so we next to the last step is conclusion. From the analysis research has carried out that the input voltage does not take more than 1 day to make it full with 100 ampere hour capacity. With this, it can be concluded that the battery capacity can be increased so that the storage capacity can be more than before. For the environmental effect problem, that there was a cloudy and accompanied by rain on 15 August 2020 and 18 August 2020, it can be seen that on that day, the voltage decreased slightly with the maximum average input voltage of 30.5 volt DC with a maximum current of 7.6 ampere. Even so, the battery remains fully charged every day and no problem with that. However, input from this environmental effect in the future can be installed like sensors and temperature sensors to determine the state of light intensity and temperature when there is a change in the environmental around the solar panel. So that's the last part in my explanation. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.